Hello and welcome to Geekatplay Studio Tutorials. In these tutorials, we continue looking on Filter Forge and mostly we'll look right now on RGB Math components. This is maybe sound boring, and in some cases you kind of need to know some of the math, but overall remember this is math will apply to the image processing and not just the kind of boring math. So one thing what I have right here, it's a profile gradient that will help us to monitor. And one thing what I'm going to change, it is change colors 1 and 2 to some values. You notice before we using colors, which is you can supply and select all these different type, including HDRIs, all different type of the colors to this, but instead that what we're going to do is just using simple controls, and we'll just have it values set, and we'll set one value to the white, so it will be 1, and another one to the black -1. Okay, you notice we can connect them to the colors as well, so it's one nice thing. So you don't necessarily need to use it the color input. You can also use it by the number input as well, and we'll take it and connect to profile. So you can notice we have it some kind of like a lines going vertically based on our profile and on the input 0 and 1. So this will help us to kind of monitor what will going on with our math. First, we take it ABS. An ABS component, it's a calculated channel-wise absolute value of models of the color supply by the source input. So you notice we don't have it any modification. We just have a simple source input. And you notice right here we have it a little bit change because it does calculating the absolute values of the input. Okay, so next we have it add, and in add again you notice this will accept the mapped input, so not just colors, but it will calculate by value. So it will take source A and a source B and take by the colors right here and add those values together. Again, with values like white is one very high and it will clip it so it won't go over range, but in other cases it will add and modify it. So you can see we have it right here, the lines of the values, so that our image kind of add together on by the color. And again, when it's calculating, it is sum all these colors that supplies in source A and B output. ABS add and other ones, they won't actually process alpha channel in that case. Okay, so and you notice this will accept HDRI, and it will also produce HDRI value on add. So let's go ahead. Next we'll take our cousins. So, and right here we actually have an interesting input. So our cousins component, it will calculate the channel wise inverse cosinus, because it's the R cosinus kind of state for this, with function the color supply from source input. So we'll go ahead, have a source right here, but also instead source, you notice we have an error. This is a mapped HDRI input, and a specified color if the operation result in an error. So if like right here we can see it's an error out, so we'll go ahead, specify different colors, and those colors will replace in a error when it's specified. So let me actually go this way, okay, and replace it. So in some cases you can see more distinguished and some not, but it's actually what will take it and modify them. Okay, let's go ahead next, and we'll go to arcsinus. It's do the same as our cosinus. It's only using a sinus to calculate on this. Okay, we also have it arctangent, which is a similar but different type of the calculation would perform, but they will act same way as the cosinus and sinuses, except right here you can notice we have just only one source, and We have options of the units where we can specify if we want degrees, radians, or rotation. So if we want just in a degrees, okay. So you can see it will accept a little bit different type of units that we can also control by our input controls. Again, those is mostly you probably will use if you go to more advanced color processing and you want to shift colors, and mostly will probably work when you start work with inside the channels, and when you start modifying with HCB or HLC some colors modification, you probably want use the math, mostly cosinus and sinus, when you start converting some colors on a shift result if you want some inversion or some other effect, but mostly you won't use that much them. Same like arctangents. And one nice things about all this, you can see formulas that apply to this. So in some cases, if you want to go ahead and calculate a refraction or some other maybe effect, you can use this function for the point xy, for the units and output as well. Again, how I say, this is a little bit kind of boring, but I want to go very fast over them. And when we start creating and using them in real life, so then you kind of start more using and appreciate. Okay, we also have a cell, and cell component, it's calculate again on a channel wise functions by the color that specify, and it's round up to the nearest discretion level. So like example, let's go ahead right here, and you can see some effect that would apply and add all those color to the nearest colors, so we don't have it all those shades. Again, we have it also granularity, which is specify the rounding threshold for this, and currently this way, and we can go ahead and maybe apply something else. So we still have it values passing through, but you see how granularity will affect our calculations. Okay, so we have it cell, we have it cosinus as well. We have it cosinus, sinuses, and tangent. So we have it all the standard function. We have a deviate, so we can calculate on that case. And again, this is will expect the source code, the source input, and a deviate, it's component that calculate again on channel wise directional deviation, the surface that's specified by source input along the direction specified by angle input. So if we want to calculate and create the normals, we can use a derivative function to calculate some of the normals. We'll specify with angles as well, so we can. Okay, and in some cases when we start calculating with normals, when we start calculating with some lightings options applying to our image, you probably one will use derive for the source and angles that is apply for that. Okay, we have it divide, and it's straightforward. It's take a deviation from the components, and I'll calculate, and again this will accept HDRI mapped input for the dividend. So we have right here divisor, and we also have an option for the error that will specify the color in operation if that come result, because sometimes you may be divided by 0 or some other ones, and in that case the color will replace if error occurred in that case. Okay, we also have it floor, and floor, it's also expect source will take as a HDRI for granularity in source, and it will produce HDRI as well, and it will round down to nearest. So if the cell will round up, for example, if you have it 5.9, the cell will produce 6, and the floor will produce 5 on 5.9, so it will go down instead up. Okay, so this is one. We also have a simple if statement. Okay, and this is more logical. So in this case, if we have it source 1, we have it source 2, and we can have it condition what is happening, and we also have it result if not the sources. Again, on the if statement, it's perform operation on a color when we supply it in our source, and obviously alpha channel won't be processing this, and it will compare the colors, and based on this will execute then or else, depend on this. One of use it if you want to replace one color with another, you actually will use that. On that case, you can specify condition, and you can specify when one color replace another, so it's kind of nicer way to work with this as well. You work on a function, you'll notice it is HDRI input accepted, and it will accept output as well. We have it options right here with operations where you specify the conditions. One, if it's A smaller than B, when it's opposite, when A less or equal, when more than equal, when the equal, or when A not equal B. So base it on these conditions. You can also specify what then happen. So we can go right here, go to the source. Again, this is very, very primitive, but you can see some little effect that can be applied depend on the conditions you specify in your operation. Okay, so let's go ahead. Next, we have a LARP, and this is calculated between two colors. Okay, let me go ahead and put it in right here, source A and source B. This is HDRI map input, and this will be used linear interpolations between two colors that will supply between different sources. Okay, let's go to source B. Okay, actually, you know what, let's go disconnect that so we kind of can see a little bit better. Okay, and of course it's will using the factor, the map input that specify interpolation factor for our image. Okay, we also have a logarithm log right here. We have it which is same as math, will apply the source based on error if the error occurred as well. Couple things, again, it will take HDRI, it's based HT. Again, those functions perform on a color range. So what is nice about all of this, it's not just one simple math function, it's applied on a mapped input. So it's take all them and perform operation on every single pixel that is input. We also have a maximum value. So if we have it between two sources, we can calculate and output the maximum. We have a minimum as well. Same things as maximum as well. Calculate minimum value and output from ours. Simple math multiplications. Again, from mapped image, when you have it 2 and it's multiplied. We also, as multiplication, we have a deviation before. We have a power, so we can apply, we can create our base, again, map input. We can have it exponential, in this case is this one, and also color on an error that is occurred. So we can specify. We can, other math is applied the root. We have a round effect as well. Okay, sinus are same as cosines before we preview. Simple subtract, where we can take one color input, map it, and subtract from this another one. Again, this is all primitive. We're looking right now on a very simple type, but when we start working with the colors, and for example, I want to remove some color when we create star field I want creating, so we will use it subtract from the color range in this case, and tangent that we looked before. So this is all very fast overlook over RGB math. Couple things I recommend for you, it is going and check documentation for a little bit more information on how they all work. They kind of will explain a little bit better in the more examples, but best way to learn them is by going by examples to what we're going to do and a practice, and we'll see how we can utilize all of these options.